Over the past 72 hours, solar radiation in the inner solar system has surged to record levels, and right now, every watt of that energy is pouring straight into one object. 3. I Atlas. NASA's latest data shows this comet-like interstellar visitor is being supercharged by the sun, absorbing more energy per second than anything of its kind ever recorded. No one knows what it's doing behind that glare, or what it will look like when it emerges again. It came from another star, moving at 60 kilometers per second, faster than any natural comet since Oumuamua. Its orbit tilts at 175 degrees, slicing across the planetary plane like a blade through glass. And in exactly 7 days, it reaches perihelion, its closest point to the sun, just 1.4 astronomical units away. The telescopes are silent. The data stream has stopped, but the sun isn't waiting. With every flare, every pulse of light, it's rewriting the surface of that interstellar stranger. And when massive solar energy collides with something not born of this system, even silence starts to sound like a warning. Right now, 3. I Atlas is invisible, not because it vanished, but because the sun itself has swallowed it from view on October 21st. The object entered what astronomers call a superior conjunction, a brief but total blind spot when it passes directly behind the sun from Earth's perspective. No telescope on the planet can safely capture it, not invisible light, not even an infrared. NASA has confirmed that there have been no new images since the observation runs in August 2025. Collected by the European Space Agency and the James Webb Space Telescope. For now, the data stream is silent. The world is waiting. The last clear image we had came from Hubble, captured on July 21st. It revealed a strange dusty teardrop drifting around its nucleus, a shimmering coma that seemed to cry light into space. But even when we can't see it, the sun can. In the vacuum of space, distance decides everything, especially when it comes to light. According to the inverse square law, when the distance to the sun is cut in half, the energy doesn't just double, it quadruples. Every meter closer means a flood of new power. An exponential rise in radiation right now. 3. I Atlas is soaking in that energy like never before. At 36 astronomical units. NASA estimates it's receiving about 735 watts per square meter of sunlight more than Mars. Far less than Earth, but an immense leap from the frozen quiet of deep space. For comparison, Earth receives about 1,364 watts per square meter. Mars gets 586. Jupiter, only 50. And out at Neptune, sunlight fades to just 1.5 watts per square meter, barely more than the glow of a candle lost in the dark. Visualize its solar energy, expanding like a giant sphere of light, radiating outward, thinning with every layer of space. The farther you go, the weaker it becomes, but as 3 Atlas divis inward. It's not just being warmed, it's being transformed. New spectral data from SphereX now confirms traces of carbon dioxide and water ice in its coma. These are the fingerprints of activation signs that sunlight is striking the surface, igniting vapor jets and reshaping the object's outer shell in real time. It's not just surviving the light, it's feeding on it. But sunlight isn't the only thing hitting it. The storm has begun. The sun is awake and it's angry. From October 11th to the 20th, NASA's Solar Dynamics Observatory recorded a surge of activity unlike anything seen all year. Sunspot groups 4,642 through 4,648 erupted in rapid succession, flooding the inner solar system with radiation and driving the X-ray flux to nearly 10 times its normal intensity. The James Webb Space Telescope and SOHO both confirmed that the most active regions were not Earth-facing, they were firing outward, straight toward the far side of the sun. In other words, directly toward 3I Atlas, hidden behind the glare. Astronomers call this the alignment window, a brief cosmic coincidence from October 24th to the 28th, when those sunspot clusters rotate into near-perfect line with 3I Atlas during its superior conjunction. If a coronal mass ejection, a massive burst of plasma from the sun's surface, erupts during this window, it could travel outward through space at hundreds of kilometers per second. At that speed, the wave would reach 4 astronomical units in just 3 to 4 days, right when 3I Atlas hits its perihelion on October 29th. And if that happens, an interstellar object that has been asleep for millions of years will be struck head-on by a storm of magnetized fire energy, dense enough to carve new scars across its surface. If that wave hits the object mid-flight, the next images could rewrite what we call a comet. Not every comet points away from the sun. Some do the opposite, they shine toward it. Astronomers call this strange illusion the anti-tail, a forward-facing glow caused by sunlight, scattering off large dust particles that trail along the comet's orbit. From our perspective on Earth, the geometry makes the tail appear reversed, as if the comet is staring straight into the light. In late August, the James Webb Space Telescope detected early signs of outgassing from 3I Atlas jets, of vapor and dust escaping into space, even when it was still 8 astronomical units away. That's far earlier than any typical comet should wake up. It means something in its thermal structure is different, maybe denser, more metallic, or simply built to endure. Meanwhile, Hubble's July observations revealed the coma expanding unusually fast, a halo of fine dust glowing like mist around a core that seems to grow brighter with each passing day. It's as if the object isn't just reacting to sunlight, it's responding to it. If its tail faces the light, maybe it's telling us where the truth lies. Science loves numbers, but when mystery meets measurement, numbers become stories. That's why NASA and independent researchers have built what they call the Alien Tech Scoreboard, a running scale from 0 to 100, ranking how unnatural 3I Atlas might be. There are 5 categories. 1. Orbit does it deviate from pure gravity? 2. Spectrum, what's the balance of water, carbon dioxide, and nickel according to Spherix data. 3. Morphology, the shape of the coma and its strange anti-tail. 4. Signal brightness fluctuations, light and dark cycles that repeat. 5. Water outgassing rate, how fast it's venting vapor into space. So far, NASA's internal assessment gives 3I Atlas about 28 out of 100, comfortably within the range of natural explanations. But the model is dynamic. If the water outgassing rate doubles after perihelion, the score could climb past 40, the threshold where things start getting interesting. On screen, 2 words appear side by side. Fact divided by speculation, reminding us that science is built not on belief, but on proof. But numbers alone don't tell stories, history does. Space has seen visitors before, silent wanderers from beyond our sun. Each one taught us something new about how fragile, or how strange, interstellar travelers can be. In 2017, we met the first one, Oumuamua. It had no visible coma, no jet activity. Yet it moved as if something unseen was pushing it. That unexplained acceleration ignited one of the biggest debates in modern astronomy. Was it a rock, a fragment, or something engineered? Then came 2I Borisov in 2019, a true comet. Glowing with gas and dust, but keeping its distance, it passed beyond Mars. During the quiet phase of the sun's solar minimum, when solar winds were weak, it behaved exactly as nature would predict: calm, cold, and fleeting. But 3I Atlas is different. It travels right along the ecliptic plane, the same path as the planets, meaning it's directly in the line of the solar wind. And this time, the Sun is in solar maximum. Its most energetic phase, early estimates suggest 3. I, Atlas, could be between 5 and 50 kilometers across, making it the largest interstellar object ever observed by humanity. Its sheer size and alignment with the Sun's most violent outbursts make it something entirely new and potentially far more revealing. But what if this isn't its first visit near a star in 1977? A brief, unexplained radio transmission shook the scientific world, a single burst of sound detected from the direction of Sagittarius, the same general region where 3I Atlas would one day appear. Astronomers called it the wow signal. It lasted just 72 seconds. And then silence. When mapped precisely, the wow signal lies about 9 degrees off from the inbound path of 3. I Atlas close enough to inspire wonder, but not close enough to claim connection. The data simply doesn't align. Both NASA and the SETI Institute have rejected claims of any repeating signals or supposed Fibonacci patterns linked to the object. The conclusion remains clear: no confirmed radio source is associated with 3I Atlas. Still, the silence leaves room for curiosity. If 3I Atlas once passed through another star system, it may carry chemical fingerprints, isotopic or molecular traces left behind by its birthplace. Those, scientists say, are worth chasing far more than any ghostly radio echo. To know where it came from, we must watch how it burns. The final week of October marks what scientists call the watch window, the crucial days when 3I Atlas emerges from behind the Sun and into view again. From October 24th to the 28th, every major observatory on Earth will be watching. The plan is simple, but vital. Astronomers will monitor 3 things first: its brightness magnitude, and the angle of its tail using coronagraph imagery from SOHO's LASCO instrument. Second, any positional drift compared with orbital predictions from ESA and JPL. And third, the correlation between X-ray flux and visible light variations. These coordinated observations will help determine whether 3I Atlas behaves like a comet or like something else entirely. And while online speculation continues to swirl, NASA has issued one firm statement: 3I Atlas poses no threat to Earth. Its closest approach remains around 8 astronomical units, roughly 270 million kilometers away. For the rest of us, this is an open invitation to join the Global Watch team to follow the live feeds, share new data, or post your own sightings in the comments below. After all, discoveries don't belong to institutions alone. They belong to those who stay curious. If it reappears exactly where we expect, science wins. If not, the story begins. As the countdown to perihelion ends, the story of 3I Atlas becomes something larger than science, a mirror held up to our own curiosity. For months, it has traveled through fire, silence, and speculation. Yet, what it truly is remains unanswered, and maybe that's the point. Every generation finds a visitor that tests our imagination. 3I Atlas isn't here to answer, it's here to ask better questions. When the new data arrives from ESA, JWST, and observatories across the world, we'll update the scoreboard and find out what the Sun has written on its surface. Until then, stay curious, stay wondering, and subscribe to follow this journey beyond the edge of light. Next time we see it, it may not look the same, and neither will we.